pick something else. So f of x equals x squared plus x minus 2, and we have 0, 4. Okay. So the average value for this function for the interval 0 to 4 is 4 minus 0, the integral from 0 to 4 from this function, which is definitely continuous here, otherwise we cannot use fundamental theorem of calculus. So I have 1/4, and then x to the third over 3 plus x squared over 2 minus 2x from 0 to 4. I only need to plug in 4. I love that. So 64 divided by 3, 16 divided by 2, and minus 8. That's even nicer. So I'll simplify. So I have 16 divided by 3. This is the average value of this function on the given interval. Can we look at some more problems now and see applications of this? Any questions so far?
Can we do 53?
Yes, let's take a look at 53. Where are you, 53? Results of practice. Okay, the keyboarders speed over 5 minutes interval is given, so we have 5 minutes here, and we have W of t. Very good, nice pick. So it's 4:14. Good. And W of t, negative 6t squared plus 12t plus 90. And the interval is 0, 5. And it is words per minute. And of course, t is in minutes. Fine. Okay. Where W is the speed in words per minute at time t. Find the speed at the beginning of the interval. So this is the speed. How do we determine the speed at the beginning of the interval? In words per minute. I forgot to stop sharing. How do I determine at the beginning? W of
0.
That's it. 0, 0, 90. 90 words per minute. Part B. Find the maximum speed and when it occurs. So how do I determine the maximum speed?
You have to use the first derivative.
Awesome. Brilliant. Thank you. Good. So let's find W prime of t. Not a big deal. It's quadratic, right? Negative 12t plus 12. Set it equal to 0, and we get t equals 1 minute. That's where we think that the maximum is. And it is, because it's a maximum. We know from algebra that this type of function has a maximum. Also, the graph is there. So we know that W of 1 will be the maximum. So negative 6 plus 12 is 6. 6 plus 90 is 96 words per minute. Any questions here? Normally, if this were not a quadratic function, I would have kindly asked you to show t, 1, 0, W prime, and show the sign, which is positive and negative. So positive, negative, so this is definitely a maximum. But you can skip this, but you have to say it's quadratic, or I'm looking at the graph, right? So it's clearly. Okay, part C. I think there is part C. Find the average speed over the 5-minute interval. how do I determine the average speed? So the average will be 1 divided by 5 minus 0, the integral from 0 to 5 from w of t dt. So 1 over 5 in front.
You're still sharing your screen.
Of course. No one is surprised. I get carried away to show this and I forget. Sorry about that. Thank you. Thank you, Nick. So 1 over b minus a, the integral from a to b from f of t dt. So 1 over 5 in front, negative 6t cubed over 3 plus 12t squared over 2 and plus 90t. I'll clean it up a little bit. Of course, from 0 to 5. Luckily, 0, when I plug in 0, everything is 0. So I have 1/5. 5 to the third, 125. 125 times 2, negative 250. 25 times 6. Oops, why am I putting the equal symbol? So how much is 25 times 6? Is it 150? You tell me. And
yes.
Plus 450. I think I'm okay. 450 minus 250 is 200. 200 plus 150 is 350 divided by 5. So I got 70. And 70, the average value on the interval 0 to 5. So 70 is what measurement unit? Of course, words per minute. Very good, interesting pick. Okay, what I would like to do is I would like to continue with the substitution rule, which is the last section of this chapter. Unless you have other preferences, I will, as you've noticed, I like to involve my students in the decision process. We're a team. Yes, I'm ready. Megan?
I was gonna see if you could do 46.
Let's take a look at 46, of course.
Thank you.
Thank you. Where are you, 46? Where is 45? I see 45. Let's see 46. Total and average daily profit. Good. So we have R prime 75 e to t minus 2t, and they're giving us an initial condition. Nice. R of t is the total accumulated revenue dollars. Okay, the company's marginal cost. Okay, we also have C prime of t, which is 75 minus 3t, and they're saying the same thing. C of 0 is 0. Okay, find the total profit from t equals 0 to t equals 10. Okay, see exercise 45. So we just have it here. That's all we have to do. We have to apply this. But we knew that that was the case. So let's, so the profit, P of t, is the integral from, we say, they said 0 to 10. Very good. From the revenue minus the cost, of course. So let me stop sharing. So that is 75 e to t minus 2t minus 75 and plus 3t dt. Okay.
Would it matter that it's the derivative?
But this is what we have. We need the integral of the derivative to find the function.
Mm-hmm.
Exactly. Yes. So we are finding the area under these graphs to give us this function. Exactly. Yes. Is that okay?
Yes.
Any questions, anyone? So the integral from 0 to 10. So 75 e to t, and this is plus t minus 75 dt. So we have 75 e to t plus t squared over 2 minus 75 t. and everything from 0 to 10. So luckily I only need to plug in 10. So 75e to 10 plus 100 over 2, which is 50, and minus 750. So it's 75e to 10 minus 700. So 75e to t minus 700. Where's my calculator? To 10, of course. 75e to 10. So 1.65 million. $6.5 if you want. Okay, part B. Is there a part B? I think there is a part B. Find the average daily profit for the first 10 days. So what do you think? It's the same thing, except it has a 1 over 10 in front, right? So in part B, profit average is 1 over 10 times this number. So 0.6165 million. Good, good pick. Thank you. Is this okay? Any questions? Okay, so I would like to continue with the last section. We may be able to finish it or may not. It's okay. So 4.5 is the last section of chapter 4. And it deals with, I didn't mean to share the screen right this moment. It deals with the substitution rule. The substitution rule is not supposed to torture us. It's supposed to give us an easier way to determine an integral, either definite or indefinite. So allow me to pick an example. I'll pick one and then we'll look at any example you want. So let's say I'm looking at 2t to the 5th minus 3 times t to the 4th dt. So you can say, I don't need any substitution rule, and I will have to agree with this. Okay? You can just simply distribute. So I have 2t to the 9th minus 3t to the 4th dt. And I get the answer as 2t to the 10th over 10 minus 3t to the 5th over 5 plus a constant c. Done. However, I want to illustrate the substitution rule because we're going to get more complicated situations in which I will not be able to distribute. So here it is. Here's the idea. And I'm going to change the problem now. I'm going to put power 10 here. So on the previous type of problem, I had power 1. I didn't have to do anything, just distribute it and the integral was done. So this is indefinite integral. But here I have a problem. It will take me some time to use either Pascal's triangle or combinatorics to raise this to the 10th power. Right? So, and I don't want to do that. So I'm looking at the function. This is the function, right? This is the integral, and this is dt that goes the integral, right? The base times height, the area, right? The sum of the areas. So I'm looking at the function, and I say this to myself. Well, if I could somehow make this disappear. Why? Because this is the difficult part. Whatever to the 10th power. I'm going to say let y, or any other letter but t, any letter you want, it doesn't matter, is 2t to the 5th minus 3. I would like to change this integral into something with y, but it has to have dy. So as you see, if the function is in t, the integral has dt. If the function is in y, the integral has to have dy. But I know how to determine dy. Anyone remembers how to determine dy? The differential, not the derivative, but the differential of y. Anyone? Anyone remembers how to find the differential of y? Well, in this case, it's 10 t to the fourth dt. The differential, not the derivative, the differential of y, dy, equals the function prime times dt, because the function has t in it. So I'm going back to my integral, and I realize that I have this piece, and I also have this piece. The only thing I'm missing is this number, but that's very easy to make up. I'm going to multiply by 10 and divide by 10. That's nothing. It's just 1. But I'm going to incorporate this and this and this in dy. I still have 1 over 10 in front. And what do I replace this by?
Y to the 10th.
That's it. I will continue solving or determining the integral using variable y, 1 over 10, y to the 11th over the 11th, plus a constant c. But now I have to go back and replace y by this. So I have 1 over 110. Y is that 2 t to the 5th minus 3 to the 11th, plus a constant c. If it's an indefinite integral, I can use any substitution I want as long as dy is in the problem. Somehow. I can always make up a number, but I cannot make up t to the 3rd or t squared. Who knows what else? So I use this substitution because this was really the most difficult part in the function. So if I could use this as the substitution, and when I determine dy, I get t to the 4th, and of course I get dt, this number can be made up, 10 over 10. I still have 1 over 10 in front because 10 and t to the 4th and dt are all right here in this. So the remainder is y to the 10th. And that's it. That's how the substitution rule works, which I think is the easiest way to explain it. Of course, we can look at anything else for 21. For 21. Okay. So let's practice. So basically, these are more involving integrals, more difficult if you want, more cumbersome, and we're using the substitution rule because